All right, today we're going to talk about something that is, believe it or not, quietly becoming the actual blueprint for the entire 3D internet. It's called OpenUSD.
So let's just start with a huge question. How do you even begin to build the metaverse? Or really, any complex virtual world? How do you get all these different 3D tools and assets and artists to all speak the same language?
Now, you've probably heard of USD and thought, oh, okay, it's just another 3D file format, like an OBJ or an FBX. But that is the single biggest misunderstanding about it. In reality, it is so much more. You have to think of it less like a file format and more like a language designed specifically to describe and build entire virtual worlds. And to really get what that means, we got to look at where this whole thing came from. The story actually starts at Pixar. Yeah, that Pixar. They invented it to solve a problem that was just getting out of control for them. How on earth do you manage these unbelievably complex movie scenes with thousands of different assets being worked on by hundreds of different artists all at the same time? And this is what it grew into. The official definition calls OpenUSD an open and extensible ecosystem. And that word, ecosystem, that's the key. It's for describing, composing, simulating, and collaborating. It's not just the final file, it's the whole creative pipeline. So why does this matter so much right now? Well, it's because basically all the biggest names in tech and creative have decided that yes, this is the future. This was a huge deal. Pixar, NVIDIA, Adobe, Apple, and Autodesk all came together to form the alliance for OpenUSD. Now look, when you see these companies, who are, let's be honest, often fierce competitors, all agree on a single standard, you know something massive is happening. They are all in. And this quote from NVIDIA's CEO, Jensen Huang, just nails the vision perfectly. He calls it the best open and extensible standard language for the 3D internet. See, they're not just thinking about a better file type, they're thinking about the very infrastructure for the next version of the web. Okay, so we know the what and the why, but how does it all actually work? What gives OpenUSD these incredible abilities? Well, it all boils down to 4 core ideas. You can pretty much think of them as its superpowers. It's really about having a much, much smarter way of putting digital worlds together from all these different pieces. And it all comes down to these 4 key pillars. Those superpowers are its composition engine, custom schemas, asset resolvers, and a rendering framework called Hydra. Together, these things create an unbelievably powerful and flexible system. So let's break them down. Okay, superpower number 1, the composition engine. The absolute best way to think about this is like layers in Photoshop. Seriously, you start with a base scene. Then, a lighting artist comes in and adds a lighting layer. An animator adds an animation layer on top of that. The key is, nothing is ever overwritten or destroyed. The system just composes them all into the final scene. You can go back and tweak one layer without breaking everything else. For huge teams, this is a total game changer for collaboration. Next up, custom schemas. This is what makes OpenUSD so future-proof. It isn't just limited to describing, the shape and color of a chair. You can extend it to describe literally anything. You could define a new schema for the physics of a car's engine, or the thermal properties of a building material for a digital twin. This extensibility means it can evolve to describe stuff we haven't even dreamed up yet. Superpower number 3, asset resolvers, gets right to the heart of how people work today. This feature basically means the data for your scene doesn't have to live in one tidy folder on one computer. Nope. It can pull assets from the cloud, from different studio servers, or it can even generate super complex geometry procedurally, just on the fly. It gives you total freedom for where and how your data lives. And finally, Hydra. Think of Hydra like a universal adapter for your TV. It doesn't care if you plug in a PlayStation, an Apple TV, or a laptop, it just knows how to display the picture. Hydra does the exact same thing for 3D rendering. It separates the scene from the engine that actually draws the picture. That means a single USD scene can be viewed in any renderer that speaks Hydra, from a super fast game engine to a pixel-perfect movie renderer, without changing a single thing in the source files. So, with those superpowers in mind, let's look at how they're actually coming together in the real world. This is where it goes from just being cool tech to a tool that is reshaping entire industries. And look, the adoption is already happening everywhere. Of course, it started in movies and TV, but now it's being used in architecture, manufacturing, scientific computing, robotics, you name it. It's quickly becoming the standard for describing any kind of complex 3D data. Let's get specific. In the auto industry, companies are using OpenUSD to build these enormous, physically accurate virtual worlds just to test self-driving cars. They can compose scenes to simulate millions, even billions of miles of driving in every weather and traffic condition you can imagine. This lets them train their AI on those super rare, dangerous edge cases in a way that would be totally impossible in the real world. Or what about this? Creating a digital twin of an entire factory. Companies are building complete one-to-one virtual copies of their real-world facilities in OpenUSD, right down to the physics of every single robot. They can then test a new assembly line or optimize a warehouse layout in the simulation, prove that it works, and save millions of dollars before a single physical bolt is turned. And that leads us right to robotics, because OpenUSD can describe physics and materials so accurately, you can build a simulation to train a robot to do a complex task, like figuring out how to pick up different kinds of fruit. That robot can then practice tens of thousands of times in the virtual world, which massively speeds up its training and makes it way more capable when it's finally deployed for real. So, here's the big takeaway. OpenUSD isn't just about making static 3D models. It's a dynamic, living framework for composing the virtual worlds of the future. This quote from Pixar's CTO, Steve May, really brings it all home. It's about creating an open foundation for fully interoperable 3D platforms. The end goal here is a seamless 3D internet, where our creations can move and be combined freely, no matter what tool we use or what industry we're in. Which leaves us with one last, really big question. For decades, we've had a universal language for 2D documents. It's HTML, and it gave us the web as we know it. Now, for the first time, we have a real contender for the language of 3D worlds. So if this is it, what are we all going to create with it?